Welcome back, everybody. All right, let's do a quick walkthrough of the fourth assignment on Module 4 this week, just to give you some tips on this. Really, this assignment here is really going to be dependent on you getting the practice quiz and the templates kind of worked out and filled out, because so much of this actually is just plugging them into those templates. So if you're having trouble with that, let me know. Otherwise, if you can work through those templates and get them set up, I hope that this is a pretty quick assignment. But I did want to go through question 1, and then I'll do another question 2, because this isn't as straightforward. It's not like one of the templates. This is what we just calculate the expected value, standard deviation of a problem that we have here. Okay. All right, so we're going to do the first one. This is a finance question. Suppose you want to buy an option. We want to evaluate, some different pieces of that option that we have here. It's going to return $100 in profit if the stock goes up, and it loses $400 if it goes down. And the probability is a 75% chance that the stock will go up. Let's figure out if this is a good deal or not. What we want to do is, what's the expected value of this profit? So if we did this repeatedly on average, what could we expect to get? And let's look at the variation in that profit too. So when you look at options, the standard deviation, sometimes the volatility can be measured using that standard deviation, the variation that's happening in the value of that option. And then just what are our interpretations of this? Like, is this a good buy? Is this not a good buy? That's what we're going to be looking for. Okay. All right, to set this up, this is what we kind of describe as a random variable. So I'll have my random variable, my outcomes here. I'll just call them X. You don't have to follow this exactly. It doesn't have to be, precisely this. So we've got our X, and then we need to know our probabilities, right? So in one state, we just want to describe like what's happening here, right? So in one state, the good state, if it goes up, we have $100 in profit. If the bad state happens, we lose 400. So these are our two states that we have right here. 100 and negative 400 are the two possibilities that can happen. So this question is a little bit different when we're looking at it. Then the question also said that the probability that the stock price goes up is 75%. So I know the probability here will be 0.75 for the good state and 25% in the bad state. And this is a good place to kind of just stop for a second and take a look. We've got our table kind of set up. We can't really design a template. If you did do the similar question I think we looked at before, you can kind of reuse that sheet if you want to sometimes, but it's nice to kind of redo these because they are just a little bit different. But the mechanics of the problem are the same. We want to find that expected value first, and to get the expected value, it makes some sense. You're going to take the product of the value, right, that we have here. So what's the outcome value, the X value, multiplied by its likelihood? So you're kind of weighting it here. So this is just going to be the X value multiplied by the probability. So we're going to just take those two. I'm using Google Sheets again, just to kind of give us a little different picture. It should be pretty same. Notice how it's actually telling us, like, it's kind of guessing what we want to do here, but I'll go ahead and type it in so you can see it. So we're going to use that X value multiplied by probability. It does want us to autofill. That would be okay. All right, now this hopefully it kind of makes sense. So we have our two outcomes here. The difference is that they don't have the same likelihood. They have different probabilities, so we want to weight the good state a little bit heavier than the bad state. But notice that even when we weight those, because even though the likelihood of the bad state's lower, the actual outcome is much worse. All right, so you can see that when we weight it, even when we weight it by the probability, it still ends up being a little worse overall. All right, then our expected value is the sum over those right here. So we can add those up. You can use AutoSum to sum across those two values that we've got, and the expected value for our option is negative $25. So easy enough, we get the expected value. Be careful interpreting these. It's kind of like a weighted average. Now, if you actually purchase this option in a very, like this is a very simplified example. Options are a little more complicated than this because they're always changing in value. But if you think about this, for the example that we're using, you can never end up with negative $25. You actually are only going to end up with positive 100 or minus 400 given the conditions of our question that we have. So this is supposed to represent then on average, if we bought this option repeatedly over and over an infinite number of times, on average we'd lose about $25 on this particular instrument that we have here. Okay. All right, so there you go. That's a little more, you don't want to get too much into the finance. Here's just the statistics on how to calculate that expected value that you've got. On average, we can see that you're going to lose money. That's probably going to tip us for the last part of the question, where is this a good idea? Since the expected value is low or negative, it's probably not a great option to buy into. The next thing we want to look at then is the standard deviation. So what's the volatility? What's the risk in this option that we have here too? We know we can go about this a couple ways. I'll do it this way. It might be slightly different than it was given before. Let me see how I'll set this one up. All right, so let's go ahead and let's get the next thing that we want to do is get the deviations around the mean. So we'll take for every x value, we'll just take x minus e of x. So we'll get these deviations around the mean as we kind of describe those. So how far away are each of these that we've got? So we'll stay here, this minus this, and remember we'll have to fix this in this case because we're subtracting off the expected value each time, and that expected value is remaining the same. So we'll just take those deviations here. Don't necessarily want to autofill, but I do want to copy. I'll just paste it here. Don't need any values right here. We're just taking those deviations around the mean that we've got. All right, now that we got those deviations around the mean, again, don't need anything here, but we got to do our next step to get that standard deviation. There's a few steps here. Now we want to know, we'll get the squared deviations around the mean, so we'll square those up, and then that's going to tell us that variation, right? So we have these deviations around the mean. If we look here, we can see you're really just checking to see how close is our x value to the average. Like, is it relatively close or is it relatively far away? So that's why we take these deviations around the mean. It's going to tell us about that variation, the variability in our random variable. So what we want to do to help show that variation is we're going to take the square of those, right? We're going to square them up. That will amplify those differences that we have. So we had x minus e of x, the deviations. Now we're going to square. These are the squared deviations around the mean. This is going to amplify if it's really far away, amplify those effects that we've got here. And then we do need to do one more thing just to describe. This will be our label, so it doesn't matter if you got this right. But after we do those squared deviations, we need to weight it, multiply it by the probability, right? So we need to multiply it by the likelihood of it happening. If that makes sense. Here we can see that this deviation around the mean, it's further away from the mean. We're going to square that deviation, so that would imply a lot of volatility, but again, we need to weight it by its likelihood of happening. So even though this is far away from the mean, we'll square the deviation, but then we're only going to weight it by its probability that we have here. Okay, all right, to do this one really quick, it should look something like this. We already have the deviation, so we just need to square it. So I'm going to use, this is our deviation around the mean, squared, and I'm going to multiply it by its probability here. So we're going to just square that deviation, square that cell that's adjacent to it, right next to it. You can autofill here or just copy paste. All right. Then now we have to remember what we're doing here. We're going to sum these up, but this value right here, the variance of x, because we haven't square rooted it. So these are the square deviations that we've got right here. In this case, we've got the variance of x is going to be the sum, if I can type this right, yeah, the sum of these values that we have here. Okay, sum them up. All right, and then our last but not least, standard deviation of x. Don't forget that step. It's easy to kind of forget it, but because there's a lot going on here, but the summation of these squared deviations around the mean weighted by the probabilities is the variance of x, and then the standard deviation of x we can get by taking the square root of that value that we have right here. So if we take the square root, we can clean this up a few places again so we can see what the standard deviation looks like and what we're working with. So we get our standard deviation. The standard deviation is about $216. Again, we would say this is pretty high, so a lot of variability, a lot of variation that's happening in our option that we have here too. So we get this measure of volatility, the variation, we get our expected value, so E of x, the expected value is negative $25, standard deviation $216. If we look at those right here, it would suggest that if we go back, what do we think? Probably not a great idea. Usually it's not a smart investment if the expected value is negative. So you could say something like that. On average, you expect to lose money. The variation is high, so high risk, low reward. That typically means not a great investment that we've got there. Okay, for these, I'm hoping that you can run through these quick. All you need to do is just identify which template to use, right? So make sure you're going through that practice quiz first and getting your templates worked out. If you notice, like here in this case, this is going to be a binomial experiment. 50% Americans believe the country is in a recession. We're going to sample 20 Americans, so that's n is 20, probability is 0.5, and then you're going to go through and calculate the probabilities for these different scenarios that we've got. You've got the expected value, you've got the standard deviation. Those should all be given to you in your template, so that's what you're looking for. Honestly, if you get that template set up right, then you can just plug in the values and it will give you the probabilities pretty quickly, which is nice. This should be hopefully kind of similar, right? You're looking at, here's a probability, default rate is 11%. You're going to sample 50 students. This hopefully sounds like a binomial again too. And so you'll go through and answer these. Okay. Here's a uniform distribution, so you get your uniform template. The same thing, it's just plugging in values. Here we have a question. This is normal, so you're just, again, just checking these values right here. I can show you really quick. Here we can just if you were interested in doing these ones, since this is normal distribution, excuse me, I'll show you really quick some examples that we've got here. I just set this up really quick. It's not exactly like what you have before, but standard normal, remember, a mean of 0, standard deviation of 1, and then to get our probabilities, I didn't do this one yet, but norm.dist. It works the same here on Google Sheets as it does in Excel. We're using this value right here. We need a mean of 0. We could even, if we wanted to, play around with some of these right here as well. I think we have to put, is it cumulative? That is true from what I'm looking for, the less than or equal to 0. Since you've worked through here already, we got 0.5, and then to get the other one, it's 1 minus that, just as a little refresher that we've got right here. Okay, so now we can plug in just to show you, but I'm hoping again you kind of have a pretty good idea of how this works. Remember, this is the trickier one, but it's a little more interesting. We're looking for those in-between probabilities, so see if I can get this one knocked out pretty fast. You're going to take the probability of the upper one, again, just using the same parameter values that we're looking for, cumulative, and then we're going to subtract off. What I really like about this one is that we're nesting these two, distribution functions that we've got in here on the same one. So norm.dist, same thing. Now we're going to just use the lower value, mean standard deviation, true. All right, you can check here if we clean this one up. Remember, we've been kind of a lot saying within plus or minus 1 standard deviation of the mean. So since the standard deviation is 1, plus or minus 1 around 0, 68.3, we kind of know that one. I think the first question was plus or minus 2 standard deviations. We know this one too. It should be really close to 95%. If you remember, that might have been a question on your last exam, 95%. There you go. So you can check exactly here with our template that we've got. So 95.4. And again, once you have this, it's just a matter of plugging these in. What's the probability of getting between 0.5 and 1.2? All right, now I just need to change my values. 0.5 was the lower value, 1.2 the upper value. So we can get our probability there too. Make sure these kind of match up with your template as well to make sure you're getting the right results. Okay, minus 1.75 to minus 1.25. So the lower value minus 1.75, 1 to minus 1.25. All right, 6.6%. Minus 1. Now we can come up to these guys right here. So now I just change my x value to minus 1. And I'm looking for the less than, I think, in this case. Yeah, so less than or equal to. I got to clean these guys up. Don't feel like you're obligated to put a bunch of 3 decimal places is plenty. Most of the time, 2 decimal places is okay too. Not a problem. So about 16%, 15.9% to get a value less than or equal to negative 1. Greater than or equal to negative 1, just the opposite of that, so 84.1% that we can see there, if I'm reading that right. Less than or equal to 1.96. If you've done some stats before, you can see this is a value that's going to pop up to us a lot. We'll see this probability. And so this is kind of an interesting one that we're looking at. I think it was less than or equal to, yep, so 97.5% at 1.96. All right, I hope this one, hopefully it's, pretty straightforward if you get your templates. I'd be careful there. If you get your templates in good shape, you'll be in good shape. All right, let me know if you have any questions. Otherwise, good luck, and I hope this one goes nice and easy.